Hello everyone and welcome back. This is the second week of Module 2. In this week we'll learn all kind of methods to fracture objects, and we're going to start with the ground crack effect. So let's go ahead and start by fracturing a simple box. So before going through an in-depth fracture workflow, just in case at some point you can't remember the exact nodes you need to break an object, let's start by using the shelf. So I'm going to select the box, let's go to the Model tab in the shelf, and let's press Shatter. Cool. Now we can see how is this going. The core of the fraction in an object is done by the Voronoi fracture. This will make a fast, easy, and reliable fracture. However, the downside is that the algorithm carries a very recognizable pattern, and we must avoid it at any cost. We'll see how to do it later. Let's get going, and I need something to collide with, but first let's make these 3 units on the y-axis. Let's make a ground plane. And then we have to convert this into RBD packed objects. So let's select this. Let's go to the rigid bodies and press RBD objects. Cool. So this will first create a rest node for future shading, the assemble node to name and pack each set of connected primitives, and this dop import network, which is importing our simulation. Let's jump to the dop network, and if I press play, we can see that this is working. Cool. Let's jump back to an object level, and I'm going to show you how the Voronoi node is working. Let's do it by creating a new geonode. And delete all of this. Dive inside. Let's create a grid. Scatter some points on it. I don't need this grid. Maybe 5. Let's drop down a Voronoi fracture. So you have to connect the first input to the geometry you want to fracture, and the second one to the points that are gonna create Voronoi cells. Let's display this, and since this is working to a 2-dimensional geometry, we don't need to create interior surface. So let's turn off this option. Now let's go to the scatter points, select it, let's press S. No, actually let's display this. Let's press S, and we want to select points, so click here or press 2, select one of them, and press T to move it. Now put the display flag on the Voronoi fracture, and now if I move around, you'll see how the Voronoi algorithm is computing the way it shatters the geometry. Let's turn on the visualization option. Cool. You can play with this a little bit. Now let's move forward and create a box. Again, a scatter node and a Voronoi fracture. Let's plug this here, maybe 50 points. And again, the geometry to fracture and the points. It could look like this has been broken properly, but if we add an explode view here, it kind of looks weird. This is because the scatter node is the Voronoi fracture node is generating new pieces from this scatter node, and this scatter node is only on the surface of the box. So to have a better fracture of this box, we need to add ISO offset here. Now, since we are scattering points on voxels, we will have an interior detail. We can pump up the resolution of this, and now you can clearly see the difference. Now, note the piece name attribute is already created in this node, so we don't need to make it by using an assemble, unless we need to have specific control of it. This is useful when we have subfractures, and that's what we are gonna see now. The first method to quickly generate subfractures of these pieces is to duplicate this workflow. So let's select this, duplicate it. We can change the seed now. We can make less pieces from the first fracture, maybe 10. Connect these lines. Set display here. And now if I change the explode view from one node to another, you can see this is already working. If you want to go this way, remember it's a good practice not to overwrite pieces, but to append a new prefix to them. For example, sub. So since this is creating a name prefix named piece, we need to change the new fracture. So let's change this to append, and maybe this to so. Now you can see that from each original piece, it's creating new fractures. But I would have much rather if you could follow another method to have way more control on how we break again these pieces. So we're gonna do the following. Let's set this off. Cool. Let's make a new for each named primitive loop connected to the first output. And now I just want to fracture only the big pieces. To do so, let's make a measure shop inside. Connect it here. Let's change this to volume. And here, the expression, $CEX is not going to work. Instead, let's use the new one called centroid of the first geometry. And as you can see here, in this help tab, we have to type uppercase D underscore and the component you want to get the centroid of. So the first one is going to be D underscore X. Now we can copy this, paste it to the other parameters, and let's change the component. Cool, now if you go to the primitive tab in the spreadsheet, you can see the volume attribute for each primitive. Now, if we want to know how big is every piece, we have to promote them and summarize all of the volume values. So let's attribute promote this. I want to go from primitive to detail of the volume attribute. Now we have the volume. If we change this promotion method to sum, now we will have the volume sum of all the volumes values written here. Cool. Now, what we want to do now is add a switch node, and if this volume value is bigger than some custom value, we're gonna break this old piece to new pieces. Otherwise, it will keep as it is. So let's go again with drop down a scatter node and a Voronoi fracture. Let's connect this here. Maybe we'll start with some points. This here. And the geometry we want to fracture on the first input. See that now we are having some new fractures. As we said, we can call this sub. If I go here, yeah, this is the piece 9, and every one of these little pieces coming from this piece 9, it's gonna have its own value, name value. Cool. Now let's connect this output here and the fractured one here. The expression you need to type here is the following: detail of the first input, the volume attribute, is bigger than some value. Now, it's much easier if we promote this value by creating a new parameter. So let's go to the parameter interface. Let's drag a float here, call it volume, apply, and then I can copy and paste relative reference here. And now we can play with this slider. This is a condition, so it's gonna either output 1 or 0, which is exactly what we need to change the output of this switch. You can see that if I play with this slider, at some point it's gonna choose not to break this piece. Cool. Before connecting this, let's promote again the volume attribute from detail to primitive. And we're doing this because I would like to visualize this attribute. Cool. Let's now add a color node, set to primitives, ram from attribute. It's going to be the volume. And we can change this from blue to red. We should lower the range. Something like this. Now, if I explode view this, what I'm seeing now is all the new fractures, but I would like to see the old fractures and how the new ones are being added to them. So let's duplicate the name attribute by primitive, by creating a primitive wrangle here. And what I want to do is to duplicate this name, but changing the name. So I'm going to say create a new old name, which is going to be the name attribute. Now, if I go here to the explode view and I change this to old name, now I can see how is doing the explode view job to the all fractures. And then if I play with this slider, you can see that it will depend on the volume attribute of the how big is each piece. Cool. Now, if you want to go one step further, you can go to the scatter node, and I would like to change this number because we are using the same amount of points for each piece. So let's turn off also the relaxed iterations to have more variation. And as you guessed, we need to have some random values here. So therefore, we need to create a new meta import node. Let's rename to it. Go here, and we need to type the well-known expression fit01 of random of detail. Let's go to the metadata node, iteration 0, close the parentheses, and maybe go over from 5 to 20. Let's hit enter. And now, if I go here and I press single pass to debug, let's select this. And you can see we have a 15 here. Let's change this. 17, 30. So every fracture will be different. It's really important that you have a unique name for each packed primitive. For example, if I go further and I assemble this, let's keep the name we had, but let's create packed geometry because I want to make a simulation out of this. Then let's quickly set the simulation workflow. I'm going to need a ground plane, our rigid body solver, our RBD packed object, gravity, merge. Okay, let's select the first contact geometry. Let's raise this a little bit. Great. If I press play here, this is going to work fine because each packed primitive has a unique name. But if I merge this with a copy of it, let's move this a little bit the x-axis, and I merge it. Let's go back to the top network and press play. And you can see here, this is complaining. And it says that object contains duplicate values for the name point attribute. So even though the simulation is still running, this will lead us to serious issues if we are working with constraints. Let's leave this Voronoi method for now, and I will introduce you to the Boolean fracturing. I'm going to use a box as well. Let's set this to 0.5. Cool. And this time I will show you how to fracture it either by using solids and surfaces. We can scatter some points on the box. Maybe 5. Let's copy some spheres to it. This needs to be as a polygon. Let's add more resolution. points, this will be the geometry, and this is the target. Maybe smaller. Perfect. Now let's add some noise to it with a mountain top. Yeah, that should work. Now I'm gonna drop down a boolean to show you all the options. So let's connect the first input to the box and the second input to the spheres. Let's leave this as by default because both of them are solid. And the operation we need is the shatter one. If you it looks like you have some issues on the viewport, so if you want to see this properly, you can change the shade to flat shaded. But in the end, it's gonna look fine if we render this. You can see that it depends strongly to the second input geometry, but at the same time, we can get rid of the bottleneck pattern and have much more control of the fracturing. So let's see it by adding an explode view here. Look at how nice these edges are. Unlike bottleneck fracture, this won't create for us the name attribute. So we have to do it manually by using an assemble node. And as always, this is going to create a name attribute for each set of connected primitives. Cool. The other way to fracture gear is to, with booleans, is to use surfaces. So let's create a new box geometry. And let's ISO offset this. Bump up the resolution. And I want to scatter some points to these voxels. Maybe this time 15. Cool. Now let's create a grid. And the method is to shatter the box using a copy of this grid with a random orientation. For this, I need a copy to points. Copy to points. The grid in the first input and the points on the second one. Now the value we have to random is the normal. So let's create a attribute normalize. Attribute randomize. Connect it here, and let's change this name to normal. We can change the distribution to, for example, inside sphere. Now we need to compute the normal again. And let's also add a mountain subnode. Without the normal node before this, the mountain sub will not work. So let's add more resolution to the grid. I can relative this parameter, maybe 80. Something like this should be fine. Maybe I'm gonna start with less grids. Cool. Now we need to drop down a boolean again, connect this to the first input, but this time I'm gonna need the B input to be a surface. So let's select this and connect the mountain here. Let's change the operation to shatter. And if I add a normal after this, Let's see how it looks with an explode view. And here we go. Fracturing using surface geometry. By the way, I haven't saved this yet, so let's do it. I'm gonna go to File, Save As. I have already created a new folder called Week 2. Let's go dive inside, and this is I'm gonna call this as Week 2 RBD, Fracture, and the version, which is 001. Let's accept this. Okay, this is quite fast as well, as you can see, if I tweak these values. Though it's not as much reliable as Voronoi fracture, so I think the perfect workflow would be always start our simulations with a Voronoi fracture to check if the collisions, scale, and constraints are working properly, and then switch it to Boolean to get much nicer edges. We're also gonna see ways to break the Voronoi pattern, but it's good for you guys if you know bot methods. Also, be careful when we have small pieces, because Bullet Solver is going to compute the mass of each piece depending on how big it is. And if you remember from the last week, and since the mass is density related, very small pieces are going to explode when colliding with big ones. So I'm going to show you a way to fix this. I have prepared a new scene for you to see this problem. Yes. And this is the simulation I have. And I made two playlists to compare. Let's hit play on both of them. And you can see on the one on the left, those tiny pieces are exploding. And it looks like this is fixed on the one on the right. So what I've done is I just drop down a geometry wrangle, and I write this. If the mass, which is a point attribute, the RBD pack object creates every time it starts a simulation, you can actually find it here in our RBD packed object. And if I go to the geometry tab, type mass, let's give it a few frames. And this is going to be the mass for each of our pieces. What I'm doing here is saying that if the mass is smaller than this value, let's turn the mass to 1. So if I bypass this and I give it a few frames again, you can see we have very small values on some pieces, like this one. So this will fix the problem, but try to avoid having these tiny pieces in the first plate. Let's jump back to a sub-level again. And regarding the new RBD nodes of Houdini 17, you can fetch them by tap and typing RBD. So you can break geometry using RBD material fracture, but I think they had assembled too many stuff in it. You can check it by diving inside. Look how huge this digital asset is. So in the end, it could be useful to set up a quickly concrete, glass or wood setups, but when you need to have control on everything, it's not very useful. Also, the 4 inputs with the 3 outputs can make these things confusing, since you can visualize them directly. Though I think RBD cluster and RBD interior detail could be useful. In the older versions, there were additional options to add to our geometry, to fracture geometry, and they were located on the Voronoi fracture. Now they split it into these two nodes. Let's grab the first one. I'm gonna, yeah, I have to change my scene, so I'm gonna cut these two nodes with Ctrl X. Let's go to this one. Yeah. So let's paste them here, and the RBD cluster is going to create clusters with our pieces, and this can help to break the Voronoi pattern. Let's actually connect it to some Voronoi fracture we have here. For example, this one. And we can visualize this cluster by clicking this icon. I let you play with these parameters here. And you can see the difference by adding an explode view. And setting the display to this one. So let's, for example, change the size of the clusters, the offset, the jitter. And this is going to change the name prefix of this attribute. And the interior detail one will subdivide the interior faces when we shatter the geometry. So let's connect these together. Let's plug the explode view here. Sorry, here. Cool. And you shouldn't need to modify anything when you're coming from Voronoi geometry. I'm going to show you how this works. As you can see, we're creating new geometry on the inside group of these pieces. Yeah, maybe this is too much detail. But when we are working with booleans, if I connect this to the boolean result, I think it's this one. Yeah, let's connect this here, and let's set explode view. There's a warning here, and it's saying that inside is not a valid group. This is because Boolean fracture is not creating the inside group for us, so we have to do it manually. To do so, let's go to the Boolean node, and let's simply turn on the B inside A. Now, if I explode view, not the interior detail, but this one, let's see if the group is created by pressing S, 9. Let's select the primitives, and here we go. You can check the B inside A group highlighted in the viewport. So maybe let's change the name to inside to follow the same workflow as we have in the Voronoi. And now this should work. Let me see. Inside. Something's wrong. Let me pause the video for a bit. Okay, here I am again, and I found the issue. It looks like the geometry needs to have a name attribute before adding some interior detail. And every time we try to add some interior detail without the attribute, it's gonna blast our geometry. So what we need is to assemble this, because remember, the Boolean is not doing it for us, and now it's gonna work. So let's see the result with an explode view, connect it here. And you can see how this node is creating new geometry in the interior surfaces. I will let you play with the detail size, noise attribute, and frequency, but of course we should keep a proxy representation of these pieces for the simulation, and those will be saved in the third input of this node. As you can see. Alright, I think now I have covered all the basics of fracturing, so let's go over to the ground crack exercise. Hello again. So before going through the process of breaking the ground, I will love you guys to take a minute to organize properly everything we have so far. Since we're no longer doing R&D, this is a mandatory step. Otherwise, you will have a mess and everything can be super confusing. Moreover, remember, you might not be the only one working on this scene. So what I've done is I named properly all the nodes. I grouped them below these minimized and colorized network boxes, and I also hide the shelf to have more space. These new render nodes will be used from Mantra outputs to call the geometry you want to render. So instead of having these inside the old ones, I cut and paste them into these new ones, as you can see. Well, that being said, let's start our crack by creating a new geonode. Let's call it crack. Dive in, and I'm gonna object merge my grid. So let's do it by, I can shift W here, and this is a mess. So a way to quickly close all these tabs is shift clicking here. Now, if I open this, this shows us as a closure. So let's grab the old grid. And now I want to trim this grid. So I will go to the render cards and let's go here again. Show this as a ghost object. And let's go to the top view. And I'm gonna trim, for example, these polygons. So plus this, non-selected, and hide other objects again. Cool. Now, there are two ways I want to show you to create the line the crack effect will follow. First one, and it's simpler, but I don't recommend you to use unless it's super art directed. It's just to draw a line with the draw curve, and let's change the projection to geometry. And now if I go to chop view, I can simply draw a line on the grid. So with this node selected, press enter on the viewport and draw a line. I press escape, and you can see that now the line is settling down on the grid. Lastly, you would like to resample this to have an even distribution of the points. So resample, and here we go. On the other hand, we can do it more procedurally, and that is transfer this into a single line. So I'm gonna scale the z-axis down using a transfer node, and I want to make this into 0. But before, as always, we have to change the pivot, and I'm gonna change this. But this time, I'm gonna save this as a preset because it's becoming a little bit annoying to do it every time. So let's go to this gear and save preset as centroid. Perfect. Now if I drop down a transfer node, I can call this preset. Now let's go back here and set this Z scale to 0. Cool, now we have a line. If you want to see the line, just switch this to a wireframe mode. Now we can fuse the points. And let's add some noise with the new H17 attribute noise sub. This one is super useful and fast, and it doesn't have as much control as doing it by a point bot, but still can be used a lot of times. So let's change the attributes to position, and I'm gonna make some noise on the XZ axis by setting this to 0. Maybe only on the Z axis. I want the noise to be centered. And now we can play with the element size and the amplitude. If we want more points, we can resample this. Let's raise up the element size and maybe less roughness. Yeah, let's leave it as it is. Now I want to keep the points only, but first let's output this as a curve, because later on we'll need it. So let's drop down an add node. And if I turn on this option, it will delete all the primitives and keep the points. You can check it by middle clicking here and here. So now I want to fracture this grid, but for the first and for the sake of the speed, let's trim it to a little piece. So let's select this. Let me see. Okay. Let's delete all the points, but these ones. And I'm gonna rename this as temp, because this is a temporarily blasting our geometry. Let's color it as red. Now we can fracture this grid, but first I want to add some jittering to these points. So let's do it by hooking a point jitter node here. And I'm gonna merge this one with another with a bigger value. So let's duplicate this one and maybe scale this to something like this. Merge them together. And actually I'm gonna delete a few of these points by using a wrangle, attribute wrangle. And I'm gonna remove points by random number script. So if random of ptnum is bigger than some value, remove point of the first input every point. Now let's create the channel, and let's say something like this. And since this script is very commonly used, I'm gonna save it as a preset as well. So save preset and rand remove. Random point remove. Save preset. Now I can call it from here as well. Let's merge this together. I don't need Y component of this. And okay, it's time to shatter the grid. So let's connect the lines and see what we get. First, let's drop down a Voronoi fracture without interior surfaces because we are breaking a two-dimensional geometry. And in the second input, I'm gonna plug the points. So I think I'm happy with this. So let's keep going by adding some noise to this pattern to break the Voronoi. And I will show you a nice trick to do it. But first, we need to reshape the input mesh. So let's drop down a remesh node, connect it, and let's see, too much. Something like this. Now we want to store the position of these points. Let's do it with a wrangle, and this is this goes with the trick I'm going to show you. So let's call a wrangle, connect it, and I'm going to store it to this new attribute called alt p, and it's going to be the same as p. So now we are duplicating this attribute. Now let's call a attribute noise again, plug it here, and let's add some X and Z noise. Center it. Maybe I can copy and reference this to have the same amount. Yeah, something like this. No need to play with this right now. And the trick is you can recover the old position, but keeping the noise on the pieces by creating a new attribute wrangle after the Voronoi fracture. So now let's connect this to the first input. Fracture this. Now it's taking more time because we have remeshed the geometry. If it's too much, we can lower the resolution. Okay, so I can visualize every piece by clicking here, this icon. And now I have to drop down a wrangle, connect it, and I want to recover the old position. So let's say position equals to vector old position. Let's set these to flat shaded. And maybe this is too much, but you can see we are starting to get some interesting noise on here. And furthermore, we are keeping the old mesh of this. Let's play with this, maybe 0.15. I don't want to wait that much, so let's set this to 0.8. And actually, you can see there is a problem here. And if we were to tweak the noise, as we are doing now, this needs everything to compute again. And it's a slow workflow. And as you can guess, I hate slow workflow, so let's do this. I'm going to create a for each named primitive loop. I'm going to connect it here. No, actually, I'm going to duplicate the Voronoi fracture. Let's break this. Okay, let's duplicate this, connect it here, using the points. Great, now let's start the loop. This should have a name primitive attribute. So this should work properly. That's for each main primitive. Yeah, here we go. And the idea is to add noise to this piece. And once we have some interesting values, I want to apply this to every piece I had before. And if I change something here, I want the same value to be automatically changed on the whole grid. So let's create an attribute noise. Again, with the position, center. Let's play with this. Not too much. Cool. Now, if I right-click here and go to the actions and create a reference copy, now I want this this noise to be applied on the other overflow. So let's delete this and plug this noise instead. So now if I change some values on here, they're going to be changed here as well, because all of the parameters are referenced from these ones. So now we can fracture this again. And recover the old position. Let's flat shade this. Yeah, I don't need interior surfaces because we're still working on two-dimensional grid. Now it looks better. And if I look closer, you can see the new patterns that are breaking this Voronoi look. And this is great. Let's go ahead by extruding this. I no longer need to see these colors, so check this out. I'm going to do it by volume extrude. Extrude volume. This depth is okay for now. And now let's assemble all the pieces to get the name attribute. And since we no longer need this alt p and yeah, this alt p attribute, we can delete it by attribute delete alt position. And we can start with the scene with this. But first, let's see how to apply a subfracture to these pieces. The main reason I want to have subfractures on this geometry is to add some detail and some pieces on these extruded polygons. If I make a explode view and see what's happening now, I can see we have no detail here. So, as usual, I'm going to need a for each name primitive loop, because remember we have a primitive attribute name here. Let's connect this. Let's take one piece, and I'm gonna do something like what we just done. So let's drop down a remesh. And now you can see this remesh node, even though it's working fine, is rounding the edges, and we don't want that. So let's use the outside group to avoid this. Let's apply it here, outside. Better. Now I can just copy and paste the nodes I used before. And those are this wrangle to set the old position attribute, the new one to recover it. Sorry, it's gonna compute this again. And the borrow refractor. So let's select all of them, copy, and paste it here. I don't want to hook anything. So let's go to manual for a bit. Set this to all position and break it and recover. Perfect. Another trick you're about to learn is how to art direct our fractures. If we know that only the pieces are near to the, let me show you. Let me set this to auto update. And I want to see the pieces. Okay. So if we know that only the pieces near to the main line have to fall, it's pointless to waste time on fracturing all pieces. For me, it will be much more efficient to apply these subfractures near the main line. So let's object merge our line. We can call it by curve. Should be here. Okay. Now let's set a density attribute of 1 with a wrangle, float density equals to 1. And I want to transfer this density to the main geo. Let's see. It looks like the curve is too big, or maybe it's we can trim it a little bit. So let's go to the points and delete until here. Unselected. Okay. Now let's attribute transfer this density. I don't need the visualization, but what I want to visualize now is the density attribute. So let's control middle click this node and click on density. We have to adjust the threshold, something like this. And let's blur this out a little bit with the attribute blur. This needs to be set on the new density attribute. Let's pump up the iterations. Yeah, something like this will work. Let's jump back to our single piece. And if you remember, in order to have fractured pieces inside our geo, we must scatter points using a fog volume. We can still use the ISO offset node, but BDBs are faster to compute. And besides, we can specify the density value of the BDB by an attribute. To do so, let's create a BDB from Polygon. Let's connect it here. And we don't want neither distance or fog BDB. Instead, we want to create our custom BDB by the density attribute. If the attribute is not shown here, it means that you have to reset the cache pass. So let's do so by cooking this again. And then if I go back to this node, here you go. Let's check this. And now we need a scatter node. I want to connect it here. And I'm not going to use force total count this time, because I want the number of points to depend of the value of this density. So let's turn this off, and yeah, this is what I need. Let's check this. Let's turn this value off, and let's fracture this. I want to see if this is working, so remember to append a new prefix like sub, and let's see. Okay, it's not fracturing anything, and this could mean this piece is far away from the main line. Let's template the grid. And I think it's working. So let's connect this to the end of the loop and check if I'm correct. Maybe you need to add more resolution on this BDB from Polygon. But as far as I can see, I think this is working properly. Let's check the previous result, the one we have now. Yeah, we definitely have more pieces here. And if I delete, now actually I'm gonna explode this one. I want to show you the interior new pieces. Here we go. If you want to use clusters to add even more variation, you can do it with the new RVD cluster node. And you have to plug it after the Voronoi fracture. So let's maybe use a clean node and a fuse node. And this will clean our geometry in case needed. Perfect. Now you might want to explode view the older pieces to see the new fractures. And to do so, let's save our old name before the loop starts. Here, for instance, I don't need this to recook. So let's say a string old name equals to this name, and this has to run over primitives. So as you can see, it's making a copy of this name attribute. Let's jump into the end, and here we have to create a new explode view and set it to the old name attribute. Let's do so. And instead of name, changes to old name. And now we can see how new fractures are being created. Those are the new fractures. And these pieces, because they are too far from the main line, there's no need to create new fractures, because they're not going to fall down. Great. Let's now pack all of this by using an assemble node. I don't need to overwrite the name we already have. Create pack geometry. And remember, we should clean the attributes we no longer need. For example, not here, but before unpacking the geometry, we should clear the density, the old position, and the old name. Let's do so. And old name. Now we can pack it. And output this as old ground. We'll end up by creating the proxy geometry. So let's again use a for each name primitive. Let's plug it here. This should work. Okay. I don't need to visualize this now. So now we'll use an amazing new H17 node called convex decomposition. This will decompose the input geometry into approximate convex segments, and it's going to speed up dramatically our simulation. So as you can see, we are going from 200,000 points to 125,000 points. Cool. So let's create another assemble node. And for catching this to disk, let's pack this. We must check that we have the same number of packed primitives as the higher resolution ground. So let's middle click here, and this number must be the same as this one. Great. So let's drop down a 5 cache node, and we can save this as, I call it ground proxy geo. Now let's save this to heap. It's fine, geo. Okay. Ground proxy / $OS DGO-SC, the current frame. Let's save this to disk. And let's output this to in ground sim. Now we are going to do a simple simulation test by activating these pieces. So let's call again the main line with an object merge. Remember, it's called curve. It should be here. Points. Okay. Maybe I can call the trimmed one, which is here. temporary curve. Let's call this instead. Perfect. Now I want to transfer an active attribute. So let's create it first. It needs to be an integer. Active equals to 1 for each point of the curve. And I want to animate how this curve is growing in order to transfer it to the pieces in an animated way. So let's drop down a carve node, and this will delete the curve from the UVs. So let's use the second U, and it looks like this is not working. So I'm gonna create a new curve from this. I'm gonna add an add node. Let's keep the points. And maybe let me just try a thing first. Maybe the UV attribute wasn't working properly, so let's call a UV texture. And if I set this to rows and columns, this is gonna create this should create a UV attribute, and I need it for points, which is gonna take the first point and set it to 0, and the last point and set it to 1. So now if I carve this, let's see if this is working. I don't know if it's gonna work. No, not working. So let's do another thing instead. I'm gonna keep these points, and I'm gonna make another add node to create lines out of these points. So let's go to the polygon tab and by group. Looks like this is not working as well. Let me pause this video and figure out a way to solve this. Okay, good news, I found the issue, and it turns out that if you want to carve a curve, the curve needs to be made only by one primitive, like this one. As you can see, we have as many points as we want, but just one primitive. And we had this before, so we had a lot of primitives. This was the first problem. So in order to solve this, I went back to the fuse node, and since this is a line, I convert this into geometry, keeping the points, and then I add another add node, and in the polygon tabs, I group them by group. Cool. So note that if you change the number of points here, maybe you have to change again when you trim the curve. The other issue is when we call the temporary curve. In order to carve it properly, we need to set the first U to 0, and then I have to move the second U. It will depend on the orientation of your pieces. You may need to do this the other way around. Cool. So let's animate this. I'm gonna set, for example, the first frame here. Let's give it several frames. Let's set this to 1. Let's see how fast this is going. Way too fast. So I'm gonna push this key farther. Let's see now. I'm gonna press V, and let's take this into a straight line. Let's see now. It looks it's taking the UV from the non-trimmed curve. So maybe let's set the animation manually. So I'm gonna go about this frame, set a key, and lower down this until this point. Now I can delete this key by shift selecting this and pressing delete. Let's see now. Still going quite fast. Let's see. Okay. Straight line again. Let's see. Now, this is what I wanted. So I don't need this window. Perfect. Now let's transfer this active attribute to the pieces. Let's use the attribute transfer from the curve to the pieces. I want to transfer the active attribute. And let's visualize it by creating a blast, connecting this here. And let's say delete everything with a value of 1 on the active attribute. Has to be points. Perfect. Let's lower the threshold. Maybe non-selected. Now these pieces are the ones that are going to be activated on the dot network. Let's hit play. Yeah, that should be fine. Alright, so let's move this output after the transfer and make sure these pieces have the required attributes, which are the active one and the name one for now. So finally, let's just create a simple RBD setup by creating a new dot network. Let's call this sim ground. Dive in. I'm gonna need, as you know, a RBD path object, rigid body solver, gravity, and since we are just testing, those 3 nodes will be enough. So let's call the proxy geometry, which is located crack in ground sim. Here we go. Now we have to convey our animated active attribute to this simulation, and that will make our pieces to go from static to active and fall down. So let's check this override attribute. Let's turn this on, and I'm overriding only the active attribute, so let's delete the other ones. Now we can maybe take a look at the guide geometry. And maybe raise just a little bit the collision padding. To have a more reliable simulation. Cool. So let's hit play. And as you can see, as far as I know, this is running super fast. Nice. Let's end this by creating a render ground geometry node. Render ground. Dive inside, and I'm gonna import my simulation here with the dot import node. Let's find the simulation. I can do it by just typing dot dot slash dot dot slash to go up 2 levels. And if I organize properly all the nodes, I will know that every simulation starts with the sim name. So now I can choose the wherever I want, which is the ground. So let's set this to fetch geometry from the network. And here we go. Also, we need the high ratio, so I'm gonna object merge it. This is on the crack of ground. This shouldn't be cooking again, so let me check what's happening. Is loading from disk? No, sorry. Oh yeah, it's cooking again because I didn't save this to disk. So let's do it. I'm gonna drop down a file cache node. Let's name as ground geo and save it in the same folder. I think it was ground proxy. So this is gonna be called ground $OS VGOSC. Current frame. Connect it here. Wait until it's done. And remember, you can also add interior detail to these pieces. So now let's save this, load it. This should have the same amount of pieces. Okay, it looks like we have some variation thing, and I think it's because we have modified the main curve. So let me pause the video and cook again this. So I've cooked again the proxy geo, and right now I have the same amount of pieces than as the high res. So let's save this again. And of course we will need to do another simulation. Let's go back here. Let's hit play. Fortunately, this is super fast. Cool. So now we can make the magic happen with the transform pieces node. This needs the same amount of packed primitives, and also the name attribute must be the same. That's why we didn't want to lose it. So let's connect the high res geo to the first input, and the template points to the second one. And if I look closer, now we are watching the proxy geo, but if I display this transform pieces node, this simulation is gonna transfer to the high res geo one. And let's add a null node and call it out_ground. So that's pretty much it for this week. Please spend some time playing with this exercise and creating new simulations. and I hope you found this interesting. See you in the next week.